So we are directly jumping to the next slot, which is presented by Jörg Niestroj. Jörg Niestroj is the CTO of Omnius, and he's talking in the next minutes about how much data one does need for in insurance contexts, and he's talking about claims automation with AI for insurance. The stage is yours, Jörg.
Yeah, hi, thank you. Okay, so I start to share my presentation, and hopefully you can see it now. First of all, I asked the question, how much data do I need, not only for the insurance industry, it's an overall question, because I got it in a lot of projects in the past, and that were not all only in the insurance business. And so therefore, because I got that question that much, I thought maybe it's a good idea to start to think about that and to find a solution. And today I want to present how to estimate the amount of data a little bit better. But first of all, some insights of me. So I graduated in mathematics and computer science, and I care about software development and data science in the companies where I'm working for. So that at the moment I work for Omnias. I joined them at the beginning of this year, and a little bit more about Omnias. Omnias is providing AI solutions for claim automations for industry for the insurance industry. So what we are doing is we want to automate the claims handling more inside of the insurance company. So to create the claim file in the core system, to do things like coverage check or claim indexing, to do a completeness check. And our solutions can be used, for example, in an EFNO solution, so where the insurance customer uses an app to file a claim, and we directly can check the police and check the coverage and do that completeness check based on invoices or on offers from the customer. But back again to the question. So how much data do I need? And as mentioned, this question is coming very often in the beginning of AI projects. And the first and simple answer is it depends. So because it's really up to the use case and the method based on that use case I choose, and also what is the quality of my data. For example, if you have 100 good lines in your data set, the model can be much better than if you have thousands of poor quality lines in your training set with a lot of noise or a lot of gaps. So therefore, it also depends then on the quality. So first of all, you have to choose your use case, and it's really important to first focus on your use case, and do not start an AI project. Start a project for a use case and discuss if you can use AI methods, and if you can use AI methods, then choose the right one, and then you can check your data if that data fits to the method, to your use case. First of all, I want to dive a little bit deeper in the use cases, but this is also just a short overview, because there are a lot of use cases that already can be fulfilled with AI, and also the methods. So I show you some preferred methods based on the use cases, but also there are always some alternatives to that. I want to show you 3 categories of use cases, and then the preferred method you can use to then check the amount of data. The first category for me is forecasting. So a lot of AI models are doing forecasts, for example, revenue forecasting or sales forecasting, churn prediction. So if you use your customer, if you lose your customers, and predict it so that you can contact them upfront, or risk assessment for new customers or new projects, for medical prognosis. These are all, so you try to predict the future, and you do it often based on structured data, so numbers or other information, booleans in the data warehouse or in your databases. And the method is regression. Often you choose regression for that, and this is that area of supervised learning methods. And so if you have a use case in that area, you can choose regression, and then you can start to think about the amount of data. Another category is facing to the customer based on semi-structured or unstructured text or voice. So incoming information from your customers via letter mail or email or chatbots, and you want to extract informations or classify documents, for example, to have the next best action guess for that, or to put it in the right process in your company. Here you use supervised learning methods like classification, extraction, or natural language processing, and for that you need or you have to structure the data a little bit. You also start maybe with an OCR upfront and then structure the data, because with that absolutely unstructured data in invoices, it's often very hard to extract the information you need. The third category is, for me, is identification and detection based on photos and images. So in the insurance industry, it's often the case that you want to do, for example, damage detection with that. And now it's getting really complex, and you need more and more data to train those models. So, for example, in that picture here, you can see a scratch on a car. But is it a scratch or is it a reflection? Also, for a human, it's not easy to distinguish between both. Therefore, it is harder also for a machine to do it. You have to train it. You have to maybe annotate a lot of data upfront, and then you have to train it based on pictures of several or different situations in life where the picture can be took to document a scratch on the car. The preferred methods here are reinforced learning or unsupervised learning. So more unsupervised learning for image detection, and more reinforced learning if you then also are in that area of autonomous driving or robotics. And methods are, for example, pattern recognition, clustering. So if you choose your use case and select your methods, so coming from that use case, you then can have a first estimation of the data you need, because this picture shows it very good that there is a difference in the methods and the amount of data you need. For traditional machine learning methods like classification or regression, it's very easy. You can start very low and it's getting better, but then you will reach a plateau. And you will recognize that it is not getting better if you provide more and more data. And in the worst case, the performance can also go down with much more data. So therefore, it is limited, the amount of data you need. Deep learning is different to that. So with deep learning, it's more like if you have more data, you will have better performance. And you should provide that much data as you can to have the best performance you can get. So that as a first overview, but I will walk through those three popular areas of AI, and starting with that area of reinforced learning, where you need no data upfront at all. So you can start without any training data sets, because reinforced learning is more about using real-time data from, for example, sensors. And it's used for example, for robots to find a way through an area, or in other areas where you interact with that environment. So you need a simulation environment that provides some real-time data, and these can come from real sensors or also from simulated sensors or data sources, but it's more about real-time data that you need. So the upfront training data set is really low, and it's all about the environment. If you choose a method from supervised learning because your use case could be solved with supervised learning, then you need some data upfront, and this data often has to be in a very good condition, or has to have a very good quality. So, for example, if you want to do a churn prediction, then you need data from your CRM, and you need maybe some features like the quantity purchased in the past, the amount of touch points in the past from the customers, the age, the gender, whatever. And so you have to select the features upfront, and then you have to maybe clean the data and find lines where not all features are set, and to fill the gaps with logic or remove that lines. And also maybe the data has to be annotated. So if you want to classify incoming documents and distinguish between invoices, applications, or terminations, then you have to annotate them upfront to give the machine a hint what is what, and then the machine can learn from that. So yeah, you have to do a lot of data preparation. It is not that much data you need maybe for unsupervised learning, the next area, but it has to be prepared very well. So amount of data, low to medium. Methods in that area of unsupervised learning. So if your use case uses methods from that area, you need more data, or you can. The performance will be better and better with more and more data. If your problem is to cluster things without knowing the classes, or if you want to find correlations and rules in your data, or if you want to reduce dimensions, for example, so the output from this can be the input for a classification to reduce some noise or to focus on really important features. Then you choose that unsupervised learning, and you need a lot of data to do that. And also the quality, the third topic, has to be discussed. Because also often the question that I get is, we already have big data, but our data scientist complains about having too little data. What happens there? So if you have a data lake with a lot of data in it, but the data is not structured, or the data is not annotated, or there is a lot of data, but it's with a lot of gaps, and you have to fill those gaps, then it doesn't count that you have a data lake or a data warehouse with that much data if it is not prepared to train a model. So, and this is really a lot of effort, and also the daily work of a data scientist is more data cleaning than really prepare methods or train methods or train models. And also, the poor quality can be unbalanced data. So you have big data, but in case of fraud detection, for example, you in 100 cases, you have one fraud case. And if you want to have 100 fraud cases to train a model, you need 100 times more data overall because of that unbalanced data in your training set. And also noise is really a problem, because if you have too much noise, too much information that is not important for the model, then you could have an overfitting, so that the model is working very well with the training data, but not in real life. So you have to think about permutations in the epochs of your training, or to use other methods to delete the noise. And also data leakage is a big problem. So if you use your CRM to train a churn prediction, and in that CRM, there's already that flag of a termination of the customers, and you train the model with that, then this is the best feature for the model, but it's not there in real life. So therefore, the model will not work in real life. So if you then choose your use case and select the method and check your data, so how to estimate it? There's several methods to do it. So there's that rule of thumb for regression, for example, that you need 10 times more data as you have features. Or in computer vision, you should have minimum 1,000 images for each class. But also this depends on the complexity of your use case. So if you want to detect a chair on an image, it's easier than to detect different colors of chairs on images. And that is, or it's getting more complex if you want to detect chairs with their brand in their color on an image. So then you may need much more images than just to detect a chair on an image. And there's also the method of Chervonkis dimensions, where you calculate the complexity of a model, and the result then gives you the complexity of that model and the dimensions, and you can calculate the amount of data you need based on that. So if you have too less data to start, then often the question is, so can I generate my own data? Yes, it's possible. And it's a misunderstanding. It's not just randomly create data. It's very complex. So you have to have variations of real life data. So for example, this cat, you can mirror it, you can rotate it, you can randomly place objects on that picture, you can make it darker or lighter or change the colors to simulate the variations that can happen in real life. So you first have to discuss the variations that can happen, and then based on that, generate your data. And it's, as mentioned, it's not easy, but it can also be a benefit if you first think about the variations, because then you may have data that you would not get in real life if the training set is too less, because you miss some of those variations in that training set in the real life data. So if you still have too little data, you should start. So just try different methods. So maybe you also get a good result with the data you already have. Or you can also think about using other methods like deterministic methods instead of stochastic methods. You can try rule engines or other methods. And at the end, there is no bad data. It's always about bad use cases or bad methods that you have to figure out or that you have to deal with, because maybe the data just don't fit you to your use case, and then you have to provide other data. Yeah, that's it.
Jörg, thanks a lot for those very interesting insights, like helping at some point companies to think about how to design their big data architecture, how to design their data landscape to develop AI-based business models in the future. Thanks a lot for this presentation.
You're welcome.